Hey, and welcome to The World Speaks JSON. Do you? My name is Phil Bratt. I'm joined by our presenter, Synergex Software Development Manager Marty Lewis. Marty, if you missed any of the sessions, I'm going to read this off again. So, since joining Synergex in 2007, Marty has worn a variety of hats as both a software engineer and a manager for the Workbench and Synergy DVL integration for Visual Studio products. He was instrumental in the delivery of traditional Synergy support for the SDI product and was more recently the architect of the new unit testing that we've kind of seen here, the unit testing support for traditional Synergy. He now serves as the company as the software development manager and works across teams to improve processes and innovate. There will be time, of course, for a Q&A session after the presentation, giving you an opportunity to use your mics. And in the meantime, you can still post questions in the chat or the QA section of the chat area to just right over there, and we'll read those off afterwards. If you have any technical issues, of course, contact classes@synergex.com, and this session is being recorded.
It was a dark and stormy night. Era. Programmers in the aughts were trying to find clever ways to transport data around in massive volume. Ajax websites were outside of hobbyist projects and seeing mainstream use in business applications. Trudging through endless amounts of XML, WSDL, and SOAP, we wrote our WCF services to meet the demand, but it was so bulky and time-consuming. The XML was hard to read, hard to compress, took up a lot of transport bandwidth, and was hard to parse. Not to mention, it was the Wild West for defining how services should operate and communicate. Times were bleak indeed. But what's that in the distance? A standard that provides just the right balance between structure, readability, and compressibility? And it's easy to parse? And it's flexible enough to transport just about any data that my application needs to move? It's too good to be true. Yes, indeed, today we are talking about JSON. The world speaks it. Do you? I'm Marty Lewis, the software development manager here at Synergex, and I'm here to distill the wonder that is JSON. In this presentation, we'll talk about a few things other than just corny stories. We will briefly go into what JSON is and why it's all the rage. We will then cover some of the many ways that it is used so you better understand why it's used everywhere. And finally, we'll talk about how best to use it with Synergy. JSON, what is it? JavaScript object notation is a standardized data interchange format registered as ISO 21778:2017 or ECMA 404 or RFC 8259. Basically, it's well understood and widely used. Its inclusion as a standard everywhere is because almost everyone can agree on the shape and requirements. The easiest way to explain JSON, though, is with a sample, not with some complicated definition. In short, JSON is a simple syntax with name-value pairs made up of values and nested objects, with support for arrays, numbers, strings, Boolean, and null values. You use curly braces to define objects, use brackets to define arrays, and literals for numbers, support negatives and exponents. And of course, you get literals for Booleans and null. JSON is well liked because it features simple, straightforward construction with only a few elements. The simple structure and the fact that it ignores whitespace outside of quoted strings means it's really easy to minify for transport. It also provides enough tools to describe your data for most purposes. And the fact that it has some support for different types makes it a bit more flexible than XML and also not quite so much structural overhead. It's supported in just about every service and context. No matter where you go, JSON payloads are accepted, and most languages have a parser. It also functions as a subset of JavaScript, which makes it immediately usable in most of your web applications. That's all pretty great. But how is it really used? Who uses it? What do they use it for? Why does it matter to your application? It really is used everywhere for about any purpose you can think of. Since it is a subset of JavaScript, it's an easy choice for a data format for any web application that needs to consume it. So, most web services support application/JSON as a transport format. It's readily available from just about any API you want to call. This also goes for APIs that need to talk to one another. No need to come up with a different interchange format from the one you use to talk to clients. You already have some sort of serialization and deserialization set up, so might as well continue to use it when talking to other APIs. And if you already have an easy way to serialize some of your data to JSON, why not use it for everything else? Want to communicate to another application over a pipe? Use JSON as your data interchange. Maybe you want a log format that has more structure to it and it's easy to parse later. JSON again. Need to set up a remote procedure call system? Design the request and responses as JSON objects. Or if you're just prototyping a data layer, it's a great temporary storage format. Or even at scale in Azure Blob Storage. For a more concrete example of how you might use it, let's say that you are in the automotive parts business and have just decided to start displaying information about your inventory on a shiny new website. I know, you've all already done this, right? You already have a database of your inventory and you need a way to transport that information to the front end. Convenient that we have a transport format for that. Let's use a few parts as an example. I have a filter and gasket from my extensive database of part info and prices. And representing that same information is as easy as building a few name value pairs. So taking this example, if I create a simple array of parts and put my part objects in it, it might look something like this. There's an outermost object that contains the whole structure, and it has a name value pair for parts. The value for that name value pair is an array, hence the brackets. And that array contains two part objects, each of which has numeric IDs, a display name, and a numeric price. It's relatively easy to parse as a human. When you look at it, you can see a clear delineation of the objects, and the data is easy to understand. When I pack this up and send it to a web application, it's also really easy to parse as a machine. But a raw block of data is not really a good single interaction type. If I'm communicating back and forth from a web application, I probably want some context. Maybe I come up with a request and response format. Since the data structure is so flexible, it's just a bunch of nested objects and key value pairs, I can build up whatever additional metadata I might need. I might put information for paginating the data, so I don't need to send too many entries in one request. Or I might add session information, or other details specifically related to my API. JSON makes it really easy to combine different bits of data model together as necessary. So here I have a response object that contains some additional information. It has the result count for my two parts. It lets the web application know that there's no pagination. We're at the end of the data. And it includes the ID of the last item, so the front end can communicate that back in case of paginated data. And finally is the parts from our previous slide, now neatly nested in the response object. The act of importing from or exporting to JSON to or from a language-specific model is usually referred to as deserialization and serialization, respectively, or serialization collectively. We'll just call it serialization. Most languages support some form of JSON serialization, either natively or through a widely available, highly performant third-party module. Some varieties of JSON libraries give you extra tools to map your types and names to your strongly typed data models, giving you single command conversion from JSON input to a local structure. No matter where you are, starting to parse is usually as easy as calling parse with a JSON input. But Where does Synergy fit into the mix? Well, in Synergy.net, you have a variety of options. Introduced in .NET Core and continuing in .NET 5 and 6, and also available as a NuGet package for earlier versions, is the system.text.json implementation. This is designed to be fast and has few complications for parsing. You call parse on a valid JSON string, get a JSON object back, and you can interrogate that object for the name value pairs that exist, retrieve members by name, which are also JSON elements, and keep moving along down the line. If you are doing new development in .NET, I would recommend System Text JSON, both because it's native and because of a reason from a future slide. You also have the option of the incredibly popular Newtonsoft JSON available from NuGet. It gives you great tools for defining your models with attributes and supports direct serialization. It can also be incredibly handy when prototyping to convert to and from your objects without a lot of boilerplate code in between. It really is as easy as the code on screen to take a JSON input string and spit back a fully baked My model, or throw an error trying if it's invalid. There are also numerous other libraries out there with their specific features for you to check out. But what about traditional Synergy? Well, we have JSON support there too. Starting in version 12.1, we introduced our own version of System Text JSON that's native to Synergy. It's still a subset of its .NET counterpart, but it is full-featured enough to let you serialize and deserialize complex objects without issue. To make sure that it will meet your needs, we dog-fooded this API in both Harmony Core as well as the traditional Synergy test framework before shipping it out as a documented feature. Also, with how we implemented this API, you can implement your serialization in a way that is directly compatible with the .NET version. So write once to get our implementation on traditional Synergy and Microsoft's implementation on .NET for your code that's shared between the two systems. What does System Text JSON look like? After you import the namespace, you have access to a few types and enums. In order to get started with processing JSON, you just need to call JSON document.parse with some kind of JSON content, either string or a handle. That's going to give you back a JSON document object with a root element property. That root element is a JSON element. And from there, everything else is JSON elements. Each element only has one value. You can find out the type of that value through the value kind property and compare that against the value kinds defined in JSON value kind enumeration, like object, array, number. If the value is an object, you can query name value pairs with getProperty or try_getProperty and the specific property name. If it's an array, you can index into the element with a standard array indexer to get the array members, which are also JSON elements. When you're not looking at an object, you can retrieve its value through get and the specific type name, like get boolean, get string, get int32, get decimal, etc. So keeping our auto parts business example, let's see what it takes to actually utilize our auto parts data structures and use JSON ourselves. So what I have already set up is a solution that is for my existing code. I've got my repository that defines my awesome part structure. Pretend that's much bigger, but ID, display name, price, that's the info from our sample. And then I've actually also written some tests for this using the test framework so that we can quickly validate that the serializer that we write actually meets our needs. Obviously, this doesn't even build right now. We are going to flesh out the type that it's going to use. I've also pre-created some test data. So I've taken that JSON that we had earlier and made it available and already minified it so that we can operate on it and write tests and run tests. So if you want to integrate JSON into your existing application, you're going to need some form of serialization and deserialization. And what I'm writing today is that code for my parts business. Everything else already exists. You already have the way that you input from your files, output to your files, interact with the user. You're just making an addition that lets you read and write JSON and makes it work with your data structures. This will do both the reading and the writing. After you've done this once or twice, maybe you want to set up CodeGen templates so that you can do this for all your structures, because I definitely wouldn't want to sit down and write this for like 100 repository structures. So starting from nothing, I know that I need system.text.json. That is where the feature comes from, and you will definitely need that. And I also need system text for my sample. What do we put in this file? We're going to be making a type. So it's going to be a class. That class needs to live in a namespace. The namespace aligns with our business. So I have my awesome parts business. And then let's go ahead and make our class. So we're going to make a parts serializer class. And actually, you know what? I'm going to use the template for that. Perfect. We're going to make a parts serializer class. And the purpose of this thing is to be able to both serialize and deserialize. So we'll set up this type. It will have a couple of methods that can be called. And at the end of the day, we should be able to read in a JSON string into our part type and output our parts to a JSON string. So the first thing that we do need a constructor. So let's get that added. And let's start with deserialization. So taking JSON input and reading it in as a part. So for my purposes, I want this to return an array of parts. So let's make our deserialize method. And I want this to be public because I need it callable outside of this scope. And oh, where did my parts come from? That's right. I have to have a repository include, right? Part repository. Note, I'm putting this in the namespace because I want my part structure to be available to anyone utilizing this namespace. I could put it in the class, I could put it in the specific scope, but I actually want this more generally available. And let's dig right into this. I know that when calling deserialize, I need to provide it the JSON that I'm actually trying to turn back into parts. So let's get the JSON data as an argument. And let's go ahead and set up a couple of fields that we're going to need here. So what were the parts of the JSON API? Well, we're going to get a JSON document. So let's get a local for that. We're also going to get a root element, which is a JSON element. Remember, everything is elements all the way down. If I remember my format, I get an array of parts. So that is also a JSON element. And then when I'm reading through that array, I'm going to get individual parts. So let's get one in here for part object. Oh, I lost my at. No matter. Now, other things that I'm going to need to do, if I'm going to iterate over that array, reading through the parts, I'll probably need to know what that array size is. So let's just get an I4 for that. An iterator, since we're iterating, that makes sense. You could call it I, but I'm going to give it a full name. The result that we're actually returning from this. And I need a temp. So I'll have a temporary part that I can read and write to as I go. The body of this method is actually pretty straightforward. Like we said on slides, all I have to do is call parse with my JSON data, and I'm going to get a document back. So if I call JS doc, JSON document the type dot parse, and provide it my JSON data, this guy returns a JSON document, JS doc. Inside of that guy is our root element. And you don't even need to store this off. You could access it off the type, but I just want to have my specific pieces in place. And that's now the outermost object of our sample. Inside of this, I need to get my parts array, right? But remember, if you take a look at one of these JSON elements, you've got all of the different methods available for all the different types because it's just one common object that encapsulates all of these different functionalities. So we know that the thing I need is an array, but we want to do a little bit of validation in the process. So let's do if root element try get property, because I want to get the property called parts off this guy. Parts. And then we tell it where we want to store that parts array. And let's make sure that the thing we got back was a array, just for sanity. JSON value kind dot array. So if we're able to get the parts property and it's an array, so for visibility, let's do that. I would need a continuation. I'm not going to do that. That would just confuse me looking at multiple ampersands. Okay, so we get the parts array back. We know it's good because we did a try get property. This only returned true if it was able to retrieve this thing. And now we can operate on it. Let's find out how big it is first. So store off our array size equals parts array dot get array length. We know it's safe to call get array length because we already validated that this thing is an array, in fact. And then let's go ahead and set up, we should do that out here. We should set up our actual result. Oh, we can't. We have to do it in here because we want to make sure we give it the right size. Result equals new part with our brand new array size. So now we know how many items we're supposed to return. Now let's iterate over that array and take a look at the parts inside of it. So iterator from 0, and this is important. Since this API is matching .NET, it's going to be 0 based by default, even though most of your Synergy code is 1 based. So we need to be very careful about that. Array size -1 because we are 0 based. And now we've got our for loop. Inside of this, what we're going to do is get each part, or get the part for this iteration, store it off into the result, and carry on, right? So part object, straight off of our array using our iterator. We know that it's 0 based, so this should be a safe match. And then result iterator.id equals part object, because we've now got our object, it's a JSON element, dot get property ID. This will get us that ID property out of our JSON string. And we know that this guy is a number. We could do a check like we did here, but for brevity's sake, let's go ahead and just straight call get int32. So this is all good and fine. We're going to get the ID property. We're going to access its value as an int32 and store it off into result.id. Except remember what I said about our array indexing. This is Synergy. This one's the .NET style. So I actually need to +1 that guy. Let's not cause an issue later. Copying that same line, we'll go ahead and grab the display name, which was display underscore name. Don't write out underscore, Marty. And we're going to access that as a string. And finally, let's get the price data. This guy was just called price. Now, I don't want to access that as an int. I want to keep my decimal info, so let's get that as a decimal. Anything else that we need to do here? We actually need to return this result. So mReturn result. So now we have a deserialized method that reads in the JSON data, gets our parts array, iterates over the parts, getting individual parts out of it, storing them into a result, which is in our structure format, and returning that back out. And if I come over to my serialization tests and deserialization tests, this one's not going to work. But maybe it'll still build. Right. So what I've done to test deserialization is I'm just reading in all of that test data. I'm creating a new instance of that serializer that we wrote. I'm calling the deserialize method with my sample data, right? And then I'm just validating the data that I know should be there. So I want to make sure that the ID of the first part was 261, the price was 2499, the string was an awesome filter, and I'm just using the assert class to validate that. If I come over to my test explorer and run test deserialize, we're green. We wrote a serializer that meets the requirements and actually, or deserializer, that reads in valid synergy data, and now we're confident that it did that as well. So let's write the other direction. Let's write the serialize method so that we can take an existing parts array and write that back out as JSON. So once again, new method. This one is called serialize. And because this is going to return a JSON string, let's go ahead and have that return a string. And opposite direction of the other one, we want to take in a parts array on this one. I don't think we need quite as many things in the record for this. We still need an iterator because we're going to iterate over the array of parts. We will need a JSON buffer of some kind. We'll need somewhere for this data to get stored into, and the easiest way to do that is going to be a string builder plus, constructing strings and concatenating them. This is why we needed system text earlier. And then we provide a type called a UTF-8 JSON writer. And what this guy does is it has some friendly methods for building up that JSON response structure, or that JSON structure, with what you hand it. So how does this work? Well, we'll need instances of things. Let's get a new string builder. And then to get our JSON writer, we're not going to construct a new instance. We're actually going to use UTF-8 JSON writer.create UTF-8 JSON writer and give it that buffer. And this tells it to go ahead and utilize our string builder for all of its construction operations. This gives us control of the object, but it lets this thing have its backing structure that it needs. So what are we actually doing when we're serializing this stuff? It's really straightforward. It's really just taking those concepts, those start objects, those start arrays, those values, and putting that into really explicit methods. So the very first thing that we're going to do is write a start object. We're going to write a write start object with no arguments because we want that empty object on the outside. Then we're going to write start array because our parts is an array. Really that easy. This is going to create the name parts with the start of a value as an array syntax. Now let's iterate over our parts from 1 to parts.length. Great. And inside of here, we're going to write out our part objects, right? So JSON writer dot write start object because we need an object for each. JSON writer dot write number, write number for our ID. So we tell it what we want the name to be, and then we tell it what we want the value to be. So parts iterator dot ID. And note, I let this guy stay one-based for the purposes because we're not actually using this to do access again on the JSON side. So we're just iterating through our one-base synergy array. And then let's go ahead and do that for the others as well. Well, display name is not a number, right? String. Parts iterator dot display name. And let's go ahead and make sure that we don't spit out all of the blanks on that alpha. So let's only write the parts that are relevant. And then let's write number for the price. And this is appropriate because remember in JSON it's just number. We don't need to specify decimal here. have our, oops, give me the IntelliSense. Perfect. Price. Okay, so now we've got our object started. We've given it its properties for ID, display name, and price. And let's go ahead and do the end object. We have to explicitly end the object when we're done, but this guy should iterate through our parts array and write out all of our parts as expected. We're not quite done though. We are almost done. This is almost a complete serializer. So we'll write the end array because we started an array here. And then, as you might expect, write an end object. And then finally, we want to return out our JSON buffer, right? String is our resulting type, so let's return JSON buffer dot toString. So one more time, we construct our string builder, construct our JSON writer. We start up the empty object on the outside. We start up our parts array, write out all of our individual parts, end the array, end the outer object, and return the result. All as a serialize, because we're taking our synergy data and serializing it out to JSON. If I come back over to my test method, so for serializing, I didn't want to have to reiterate all of my types in here, so I'm actually just going to go ahead and borrow the deserialize. So we read in all the JSON data, we construct a serializer, we deserialize the sample data into a parts array, and then we're reserializing that parts array into a result. And then we're just comparing the original sample data versus our serialized result. This is a round-tripping test, essentially, to make sure that what we started with and what we ended with are the same when it runs through our process. So if I come back over to the test explorer, oh, I need to build. We see our new test in here. And we're green. So when we round trip this result, when we serialize and then deserialize with our very simple code, it produces the same result. And now I can use JSON for anything I want to do in my application. I can read in bulk entries, I can communicate with other processes, I can just spit things down from my web service and consume it in my Synergy side. It opens up a lot of doors and doesn't force you into some position where you need some custom format to talk between your other apps in Synergy. So why use the Synergy JSON API? As we've discussed, there are a lot of positives to JSON, but it's also pretty much inescapable. Chances are good that most of you have some piece of code, web service, or other part of your source base that's already interacting with JSON. The JSON API in Synergy opens up additional doors for using JSON in more parts of your systems. It standardizes data interchange formats for everything, which is good for you and good for others, and it simplifies your decision-making for input and output formats. Finally, it lets you continue to use your existing data models. Write the serialization code, or even better, write a template for CodeGen and let CodeGen generate the code for you based on your repository structures. And with that, who has the first question?
And we're back. So for those of you who aren't looking at chat, I will say, so Dan did put an additional tip while looking at Marty's coding on the screen. Dan says, I find it useful to put a comment identifier next to each write start object so that you can make sure, so I can make sure that I have the matching write end object. So, yep, yes, solid advice. And then Marty chimed in with, I also really like to use defines for all the identifiers for the serialization so that it's faster to change out names if you need to for the readability of the demo. I omitted that. So yeah, I mean, obviously you only have so much time, so, you know, got to put in what you can in there. We do have a question from Deem, and of course, we are doing our Q&A. So if there is a raise hand icon at the bottom right, if you want to use that, or if you want to just type into the chat or the QA sections of the chat window to ask questions. But Nadim does ask, in DBL, we have Synergix libraries to create XML files. And do we have similar libraries to create and read JSON files? maybe a little out of topic.
Yeah, so the system text JSON that I showed in that demo is actually the Synergex implementation of how to create and read JSON files. So following that demo, you can set up your code to read the JSON in whichever way is appropriate for your application. The idea is to probably have it read and write your data structures. And so that shows you how to kind of massage it to read and write in a way that's compatible with what you've already created.
Yeah, awesome. And on that note, with JSON being new and shiny and all that, well, not really new, but are we still supporting XML with our within Synergy?
Yeah, absolutely. There's the XML API is not going away unless 100% of Synergex customers come back and say we don't use this anymore. We just want to make sure that all of the data formats that you're most likely to encounter are supported.
I don't want to play with this anymore. There you go. So I noticed in there that you did say that there were some reasons you use system JSON over the, in your own words, the popular Newtonsoft. What were your decisions in doing that?
It's mostly about what Microsoft decided to do as their own native native JSON support. They implemented system text JSON to be kind of low level and just really fast.
Mm-hmm.
And so it was a pretty easy decision for us to say let's match what's available in the new versions of .NET, make that capability available for traditional Synergy users as well. There's definitely some niceties in the other libraries, but kind of keeping in theme with other things we've done in Synergy, it's just low level and fast and gets you a good functional experience.
Yeah, absolutely. I understand that. Now, you did mention that traditional is a subset, I'm assuming, of the Synergy.net language. What exactly do you mean by a subset? What do we not? Is there some stuff we don't have available in traditional?
Yeah, there are a few more tools available in the .NET implementation that let you get the list of properties that are inside of a given JSON element.
Oh, sure.
We ran into some challenges in getting that to be performant or work in a way that matched, especially with kind of the differences in what we support in terms of enumeration. So we are still looking at ways to give a little bit more of that feature set availability. I know I particularly like to be able to abstractly iterate on JSON objects and not have to know every identifier in order to use it. I do anticipate that we will get closer to full parity, but it is a subset, though a fully functional subset.
Yeah. Awesome. Yeah, all the bases that you need are there for sure. So awesome. I'm not seeing any more questions. So I think we're going to go ahead and wrap this up. Thank you everyone for joining. Be sure to check out tomorrow for our final sessions. And there's Chuck. Thanks for right at the bell. Thanks, Chuck. All right. So any thoughts on using JSON to replace some traditional Synergy protocols like XSOR Plus or SQL connection?
So we kind of already have. You could think of like the Harmony Core traditional bridge as replacement for XF Server Plus, doing the remote procedure call, and that is using JSON. So the whole transport mechanism for that is JSON data to carry the instructions and the results back and forth across. Hadn't thought of it for SQL connection. So if you've got ideas of what that would look like or what you're thinking there, I'd be interested to hear more about it.
Absolutely. I was like, yeah, because the rest of Chuck's comment is would be cool to have SQL connection push JSON to an event pipeline to update Snowflake. And I was like, okay, I see you, Chuck. That's cool. I like it. Dan did say that the code would be quite easy to code generate. Oh yeah, you could code generate to serialize records contents from a repository. So but yeah, some built-in stuff, also a solid idea. So if there's feedback on our community for you could do an ideas post, or you could just post that over to support@synergex.com, of course, as well, and we can guide you on getting that to the devs. I mean, this is conference is always a great time to kind of speak directly to developers such as Marty, who touches all the things. So like when it comes to the Synergex products. So awesome. All right. I think on that note, yes, awesome. So tomorrow's sessions, we have our final sessions with our exciting guest speaker, Henrico Dolphin, talking about why big technology projects fail, which I'm very excited for, because that is a crazy topic to touch. And I hope there's stories, because I always love anecdotal, like, here's how this thing collapsed. And then, of course, our wrap up from the Synergex president, Bill Mooney. So always a fun time. I love listening to Bill's talk as well. Just that enthusiasm. So, and on that note, we'll go ahead and wrap up. Thank you, everyone, and have a good one. See y'all.
Thank you, everyone.